In this final tutorial, we will learn factor by grouping. So here is our factor by grouping, and we do this when we have a cubic that has all four terms. Now clearly this is no longer a binomial, but the good news is it's actually not a trinomial either. So when it has four terms, it still is a sort of a special pattern. We're going to factor this by grouping. What we're going to do is we're going to take the first two terms and group them together. So I'll just call that a group. This will be my red group. And we're going to take the second two terms and we're going to group them together as well. So I'll call this my blue group. So what we're going to do, step one, we're going to factor a GCF from each group. Now, there is not a GCF among all four of these terms, no. But if I just group the first two terms together, there is a GCF. I see a 2 and a 6, so a 2 can be pulled out. I see 3 factors of x here and 2 factors of x here, so I can take out the 2 factors of x. That's the most that are in common. I'm going to factor out my 2x squared from my first two terms, and I will be left with, well, if I divide the 2 out, then it'll just be a 1 inside. If I had 3 factors of x and I divided 2 away, I'd be left with 1 factor of x. I have my plus sign, of course. 6 divided by the 2 will yield a 3. And of course, I had 2 factors of x, but I divided them out, so there's no more x's in that term. So I factored the GCF out of the red group. Let's look at the blue group, these two terms. I see another GCF here, and it's a 5. Just a 5, just a number. And since it's a positive 5, I'm going to factor out a positive 5. And let's see what's left. If I divide the 5 away from the 5x, I'm just left with x, and then a plus sign. And if I take the 15 and divide by the 5, I'm left with the 3. So what I've done, I've taken these four terms and now I've factored and I'm left with two terms. I have this red term and I have this blue term. Terms are separated by pluses and minuses. So now what I need to do is factor a little bit more. Now if you see this red term and this blue term, there is one more thing that's in common with these terms. They both share this x plus 3. They both share a factor of x plus 3. So we can factor the binomial GCF. We have another GCF that's being shared with these two terms. I'm going to factor, now we don't typically factor out a GCF that's a binomial. Usually it's just a little monomial we take out, the 5 or the 2x squared. But if a binomial is shared, we can factor out a binomial as well. And I'm left with x plus 3 factored outside, and whatever's left is going to go inside our parentheses. Now let's see what's left. If I take the factor of x plus 3 away from the red term, I'm left with 2x squared. And if I take the factor of x plus 3 and divide it away from the blue term, I'm left with plus 5. And look what I've done. I factored my original cubic. This 2x squared has come right here. And this 5 has come right here. So let's look at this process again. I have four terms, and that's the big indicator that there's something funny going on with this, and most likely I'm going to be factoring by grouping. I group the first two terms together, and I pull out the GCF, and I'm left with a binomial inside the parentheses. I take the second two terms and I pull out the GCF and I'm left with a binomial. If you can factor by grouping, these binomials will be identical. And if they are, then you can factor out the binomials and be left with the two pieces of the terms left in the other set of parentheses. And there we go, we factored in. Let's practice again and see if we can make sense of this. So here are my four terms. They're in order. We have degree 3, and then degree 2, and then degree 1, and then a little a to the 0, degree 0. So I'm going to first group these terms together first and find the GCF. And I see that there's an a squared. So I'm going to factor out a squared. If I factor out a squared from a cubed, I'm left with a, and then a plus sign. I take the a squared out, and I'm left with 7. I'm going to continue to color code, and perhaps you have colored pencils or colored pens as well. I'm going to take the second two terms, and I see that the 3 and the 21, they both have a 3 in them. But this one, because it's a negative 3 to begin with, I'm going to factor out a negative 3. Now watch out when you're dividing by negative 3. If I divide this term by negative 3 and divide this term by negative 3, this becomes a positive a and a positive 7. Now I know that I've done something right because look at that. The parentheses are identical. I'm going to take the two sets of parentheses. I'm going to factor them out as a GCF, a plus 7. And I'm going to open up a set of parentheses for anything that's left. The things that are left are right here. This a squared and this negative 3. And I'm finished. I think it's a pretty neat way to factor. Let's try another one. Example 7. Let's see what we have here. Again, I see four terms, so I'm going to try factor by grouping. I'll take the first two and group them together. I see a 10x cubed and a 5x squared, so I'm going to factor out a 5 and an x squared. That's the most that's in common. And let's see, and if you like to put the little 5x squared and divide underneath it, each one of these, that's fine. 10 divided by 5 is 2. X cubed divided by x squared, there's an x still. I've got the plus sign. 5x squared divided by 5x squared, anything over itself should be 1. And let's group these terms together. And I see a 4 and a 2, so they're both even. I'll take out a 2. And it is a positive that I'm going to take out, positive 2. And I'll be left with, let's see what I'm left with if I divide by 2. 4x divided by 2 is 2x. And 2 divided by 2 is 1. And of course, I keep the same sign. Great. I know that I've sort of got my little checking tool here. The parentheses are identical. So I'm going to take the parentheses and I'm going to factor them out as a GCF, 2x plus 1. And I'm going to set up another set of parentheses for the other things that remain. That's the 5x squared, and that's the plus 2. Neat. Finished. All right. Well, why do you say I have another example? Well, it seems pretty easy. There's one more thing that might happen, and let's see what happens in example 8. 1, 2, 3, 4 terms. Okay, I'll factor by grouping. Group these guys together first, and let's see, they both have an x. Oop, they both have two x's. I'll pull out an x squared. And if I pull out an x squared, maybe I write it underneath it. I've got 2x from this first one, a plus sign. X squared divided by x squared is 1. Okay, not too bad. And let's group these together. I see 18, I see 9. So the factor that's in common is 9. But again, because it's leading with a negative, I'm going to take out negative 9. And let's see what's left. Negative 9, I'm dividing. Negative divided by negative makes a positive 2, and of course the x. Negative divided by negative makes a positive and a 1. So, yep, I've got identical sets of parentheses. So I'm going to factor that out as the 2x plus 1. And let's see what remains. I've got this x squared that'll go here from the first term, right? I've got my red term. I factored out this 2x plus 1, so x squared remains. I've got my purple term, and I take the 2x plus 1 and factor that out, so the minus 9 remains. Okay, we're not finished. I hope that you see why we're not finished. This goes back to the first tutorial from today. This 2x plus 1, well, there's nothing to do with that, just like there's nothing to do with this 2x plus 1. But this we can do more with. This is a difference of two perfect squares. We can factor x squared minus 9 a little bit more. So the 2x plus 1, we're not doing anything more with that. But the x squared minus 9, take apart the x squared into x times x, take apart the 9 into 3 times 3, and we've got x in the front, 3 in the back, one's plus, one's minus, and that's complete. So just because you can do factor by grouping doesn't mean you're necessarily finished. There might be a difference of two squares that you can do more with. Now, of course, we couldn't do anything more with this because this is a sum of two, and they're not even perfect squares. So go back to the previous example. Why couldn't we go more with this? This is a difference. This is a perfect square, but 3 is not a perfect square. Your perfect squares are 1, 4, 9, 16, 25, etc. So I wanted to show you this one to show you that you could do more. That's factor by grouping. Thanks for watching this last tutorial. I'll see you in class, and we'll practice some more. Bye-bye.